Hey guys, welcome back on Listed Code. So today's problem of the day is count all possible paths from top left to bottom right. What we need to do in this, let me just show you an example. Suppose you are given a new grade for m equals to, in this case, you can say that m you are given as 3 and n is also 3. M is the number of rows and n is the number of columns. So in this case, you're given m equals to 3 and n equals to 3. Now you need to find the number of paths from this point to the end of the grid. That is this, between these. So the first path which you can find is like this. The next path which you can think of can be this. Another path which you can find would be like this. Another part can be like, you know, like this. And the next part which you can think of will be like this. And one more part which you can think of would be like this. And one more part which you can think of can be like this. Right. And we need a mistake here that this purple part and the blue part are exactly same. So let me just remove this part because this is the same part as the blue one. All right. These are the all parts which are different parts which are possible. So you can see the count of such parts will be 6. So like this, we will be given any grid and we need to find the number of paths possible from starting till the end. So how to solve this problem? We can solve this problem using recursion. For example, if from the starting I'm here, like I need to consider how many ways are there for me to go. For this case, I can go either to the right or to the left. So I can say I have 2 ways. Now, same goes for this place also, for this place also. And now for these corner, for these places at these end. For this place, I can only go to downward direction. So I have only one way to go down. And also for this place, I can go only to the right direction. So for this place also I have only one. Same goes for this case and for this case. And for this last place, I have only one way. That is to not go anywhere. So for these edge cases, or you will say these corners or at this side, you have only one way. And for the rest of the matrix, you have 2 ways to go. How to code this out? Now let's check that out. Okay, so before starting to code, I would like to mention one more thing there, that there in this problem, we can see overlapping subproblems. What do I mean by that? You can see that if I started from here and suppose I went here and then here, so what am I doing at all the points? I'm just checking for this point, how many ways are there from right and from left. Same, I'm checking from here, how many ways. I'm just adding the number of ways from right and from down. Same, I'm going here, the number of ways from right and from down. Now, this is one part. Suppose I came from a second path from this to here and then this. Now, I'm going to again check the same thing. How many ways are from right and from downwards, which I've already taken care of in the previous path. So I am having overlapping subproblems which are increasing my time complexity. So here we can simply use dynamic programming to reduce the time complexity. So we can just store the value which we got here for the right and the number of ways from this path to the end. We can just store this value in our DP matrix, and so that whenever we reach here from another path, we can just use that value parity and we do not need to calculate it again. So having said that, now let's go and code this problem. First of all, let's just create a DP matrix. Let's call it DP. Its size is going to be of m, and the columns in it are, and yeah, one more thing, there should be a long num and then factor of long num and the column size. And let's fill this with value 1 because let's say this is our DP matrix. Then how are we going to fill it? So see, we can just fill this value as 1 and this one as 5. And now see, for uh, either we can start from here or here. Now for coming to this portion or this middle area, we have only two ways, from top or bottom. So there could be this number of total ways will be top plus left on this one. That is 1 plus 1 and that is 2. Now similarly for this area, the number of ways will be 2 plus 1. That becomes 3. Similarly for this area, the number of ways will be 2 plus 1. That is 3. And for the final destination, the number of ways become 6. In this fashion, we are going to create a DP matrix. Let's just create it. We have created it for, initialized it with all ones. Now we need to take care of these areas. So let's just do that. So I can just say for int I equals to 1, I less than m, and I plus plus. And for the columns as int j equals to 1, j less than m, and j plus plus. What we want that dp of I and j should be equals to dp of I and j minus 1 incremented by dp and I minus 1 j. And we need to take a modulo m. Okay, now let's write a modulo int m's value as 29 plus 7. Resistant upon 9 plus 7. That's it. And then we just need to return our dp of m minus 1 and m minus 1. And that should be it. Now let's try running this for the case. For the maximum case, that is m equals to 100 and n equals to 100. And let's see if it is working. Okay, there's one problem. We just tried an int here. Now it should be working fine. Now I'll submit this code. And we have solved this problem successfully, and I hope you liked the explanation. And if you did so, make sure to hit the like button and subscribe to this channel. And I will see you tomorrow with the next problem of the day.